The next section we're going to talk about is section 3.3, trigonometry substitutions. So there are three different cases. The first one we're talking about is involving the equation, the function we have square root of a squared minus x squared form. So section 3.3 is different than the other sections involving trigonometries. Here in the section 3.3 trigonometry substitutions, our function is going to be normal functions, like you're going to see x, you're going to see x squared, square root. You're not actually going to see any of the tricks, like trig functions, sine, cosines. But what we actually want to do is we want to rewrite x in terms of sine, cosine, secant, tangent. So we can solve this one in terms of a trigonometry function. So the first case, we're going to talking about the integrals involving square root of a squared minus x squared. So the goal here is actually we want to, using the identity, or actually not identity, we want to use the triangle. So we want to set x is equals to a sine of theta. So sine of theta is going to equal to x over a. According to the right triangle, sine of theta is the opposite over the hypotenuse. Then the adjacent is just going to be square root of a squared minus x squared. So this is the basic idea we want to use, so we can replace x with some kind of sine, cosine, depending on the situation we have. And then we're going to using the triangles, the definition of the trig functions, to solve them, in particularly to replace back. So this is the case. We have square root of a squared minus x squared. So we want to set x equal to a sine of theta. So the example we will see right now is the integral of square root of 9 minus x squared dx, where a, or a squared, is going to be 9, so a is going to be 3. So we're going to let x equals to 3 sine of theta. Then dx is going to be 3 cosine of theta d theta. And what we're going to do is we're going to replace dx with 3 cosine theta d theta, and we're going to replace x with 3 sine theta, so x squared is going to be 9 sine squared theta. And 9 minus 9 sine squared theta, we can factor it out using the Pythagorean identities to rewrite 1 minus sine squared theta as cosine squared. And we can simplify it to get integral 3 cosine theta times 3 cosine theta d theta, which is integral 9 cosine squared theta d theta. Now this is the integral I actually need to solve. So pretty much from here to here, what I'm doing is I'm using the substitutions and also try my best to simplify the function. Okay, continue. We want to solve integral of cosine squared theta. which from the previous section, we can using the half angle identities. So put out the constant 9, and then the cosine square theta can be rewrite as 1/2 plus 1/2 cosine of 2 theta. Which the integral is pretty straightforward. 1/2 is going to be 1/2 times theta. And then the 1/2 cosine of 2 theta is going to be 1/2 multiplied by another 1/2 from the antiderivative of cosine 2 theta times sine of 2 theta. Undo the chain rule. So putting everything back together, we got 9/2 theta plus 9/4 sine of 2 theta. And then I'm going to keep rewriting it using the identities. Sine of 2 theta is going to be 2 times sine of theta cosine of theta. Why I have to rewrite it in terms of sine theta cosine theta is because of the right triangle here. So after I find the integrals, I need to replace it back. So there's no more thetas, it's only going to be x. According to our original setup, so for this problem, what we have is x equal to 3 sine of theta. So sine of theta is going to be x/3, which is the opposite hypotenuse, and then square root of 9 minus x squared is going to be the adjacent. So we will have cosine of theta is going to be the the adjacent over the hypotenuse. And then theta is just going to be the antiderivative, the inverse arcsine of x/3. So putting everything back together, we got 9/2 times arcsine of x/3 plus 9/2 by multiplying the 2 and the 9/4 times cosine of theta, which is x/3, times sine of theta, which is x/3, and then cosine of theta, which is square root of 9 minus x squared over 3. And then combining everything together, we ended up with, I ran out of space, so I'm going to cross out the 9 and then the 3. So we ended up with I ran out of space, so I'm going to just rewrite this whole thing as x/2 square root of 9 minus x squared plus c. And that is the answer for the first example. So a really quick recap. We're talking about the situation that is square root of a squared minus x squared, and then we're going to let x equal to a sine of theta. At the beginning, we are substituting the x and the dx in terms of theta or sine of cosine theta, and then the d theta. And then we're going to using identities to simplify them. So we end up with a trig integral. So we go back to section 3.2. And once we had the trig integral, depending on the situations we have, here we're using the the half angle formulas, I got sine of 2 theta, which using the reverse directions of the chain rule, I got sine of 2 theta over 2. Multiply them, rewriting the sine of 2 theta using the double angle formulas because of the right triangle here. So I can replace sine of theta, cosine of theta, and then the theta. So a quick reminder that this one is the arc sine. It is the inverse function of the sine. So this is the inverse function symbol. It's not the negative 1's power.